Hello and welcome. This is Jim Kaufman with Rankin Technical College. In this video, we're going to take a look at building arrays and controlling flow. So in this, we'll go ahead and look at arrays for storing data, HTML collections, loops, or the different methods for arrays, array methods, understand different decision structures, and flow control. So arrays and controlling flow. So controlling flow means changing the order in which the JavaScript code executes. All right. Arrays give you a way to store many related values under a single name. Loops let you repeat code automatically. Decision structures let your program choose between different paths. So together, all of these tools let a script react intelligently to data instead of running the same fixed sequence every time. So storing data in arrays, declaring and initializing arrays. So an array is a set of data represented by a single variable name. Rather than creating a separate variable for each value, for every value, an array groups related values together so they can be managed as one unit. The most common way to create an array is with an array literal. An array literal is a single statement that declares the variable and lists its starting values inside square brackets. So here's an example here where you've got a variable array name, okay? And this is considered an array literal. So in this case, you're going to be using the brackets, right? Beginning and ending bracket, and you'll put your values in there, comma separated, okay? Here is an example of menu items where you got sourdough loaf, cinnamon roll, right, etc. And then here you've got, so this is an array of strings, different strings, right? This is an array of numbers where you've got 12, 8, 19, 5, right? So an array can be created using the array constructor with the new keyword. Although the array literal syntax above is far more common in modern code. So basically, when you do use the array keyword, okay, you're going to put these in parentheses instead. Okay, so it's kind of just personal preference. I think the important thing is obviously the important thing is just be consistent. You don't want to do it one way at one point in your code and do it a different way in your other point in your code, right? So there's really no reason to use it different ways. You just do however you want to do it, right? But be consistent. I guess you're adding a couple different more keystrokes. Just you have to put new array here. The important thing is obviously if you use the array constructor, you need to use the open and close parentheses. Whenever you're using some kind of a constructor, you're always using parentheses. Okay. Obviously, this is a shortcut where you just use the brackets itself. Elements and indexes. So each individual value stored in an array is called an element. Okay. Every element has a numeric position called its index. Indexes always begin with 0. So the first element of an index of 0, right? So the first element has an index of 0, sorry, and the second one has an index of 1, and so on. So I think pretty much at this point, everybody in this class at this point has already taken the C# course last semester. I think we did have somebody that was newer, but at this point, everybody's already has a little background in arrays and so forth from C#. So this should be much easier to pick up these concepts. Some things are a little different with JavaScript than they are with C# and other programming languages for arrays, but there's a lot of carryover here that makes things easier to understand. So in this case, you've got a variable called array called baked goods here, right? So the first one, loaf, is at index 0. The second one is at index 1, etc., right? Bagels at index 2, and then muffin is at index 3. So then to access those, right, here you're just doing a document.write, use the name of your array, right? And then in brackets, right, you just put the number, right, the index. So in this case, you got a 0, so 0 is going to be loaf. Here you've got 2. 2 is going to be what? Bagel. Now you can also reassign an existing element to a new value, right? In this case, we're saying go ahead and reassign baked goods at index 1, which is roll, and assign that the value of croissant. Okay. Sparse arrays and length property. Okay. So a sparse array is an array in which some elements are left undefined, making the array's length greater than the number of values actually assigned. The length property returns the total number of elements, including any undefined gaps, not just the elements with assigned values. Okay, so in this case, you're defining an array called ticket numbers and being an empty array, right? Then you can actually start. Then you're adding some ones, and at index 0, you've got one. You're assigning the value 101. At index 5, at 106, right? So indexes 1 through 4 are left undefined. Okay. So now when you do that and you check the length of that array, okay, that array is going to be a 6 and not a 2, right? It's going to be 6. It's going to, because it allocated memory for all of those, right? So unlike many other programming languages, JavaScript does not require every element array to share the same data type. A single array can mix strings, numbers, and booleans freely. So as you recall, like in C# and other programming languages usually define something maybe as an integer or a string. You have to state what that array holds, right? And then everything in that array's got to be that type, right? Very, very type sensitive, right? Well, JavaScript is very loose. You can put any kind of, you can put a string, an integer, a floating point, all kinds of things, a boolean, all these different things in an array, right? In the same array, right? Now, there might be some reasons that you want to do that, but it's kind of sometimes a little too loose, right? You can get away with a little too much, but just kind of mentioning that. Okay, but a single array can mix strings. You can have all those different kinds of types in there, right? Multi-dimensional arrays. So basically, a matrix is a rectangular grid of values arranged in rows and columns. JavaScript has no built-in matrix type, but a multi-dimensional array achieves the same results by nesting one or more arrays inside another array. Each nested array acts as a row of the matrix, right? So in this case here, this is a multi-dimensional array representing 3 shelf bakery display. So you got this display case, right? And then where each inner array is one shelf of item names, right? So on the first shelf you've got croissant in Danish, right? And then etc. Okay. Referencing row 1, column 2. So to reference, right? To reference this you go to the first index, right? This would be the 0 index. This would be the first index. So of your multi-dimensional array, the first one in brackets is going to be which one of these, which one, and then in this case, it's going to be this one, right? Then you're going to count 0, 1, 2. right? And this is going to write right. Number of rows. So here, you're doing the display case dot length, right? So your length here is the number of rows, right? So this is like 1, 2, 3. Okay. Now, if you wanted to number of columns, items in the second shelf, right? So in this one here, you would use the display case down here, display case at index 1, which is here. Then you get the length, right? And that will also return 3. When to use multidimensional arrays. Multidimensional arrays work well for grid-like data, such as a calendar, a seating chart, or a spreadsheet of rows and columns. Things that are going to make sense for rows and columns. For simple lists or related values, a single dimension array is usually clearer and easier to maintain. Okay, exploring HTML collections. So the document object model, which is called the DOM, right, organizes groups of HTML elements of the same type into an HTML collection object. An HTML collection shares many features with an array. Elements are accessed by numeric index, and a length property reports how many elements the collection contains. Unlike an array, an HTML collection updates automatically whenever matching elements are added or removed from the page. Okay? Referencing an element within a collection. So an elements in a collection can be referenced either by their index number or by the value of their ID attribute. Okay? So in this case, we have 2 paragraphs. Okay? They have different IDs, which they should, right? ID should be unique, but you got 2 paragraphs. So in this case, you've got a collection of every P element on the page. So this will grab every P element that you have on your page by tag name, right? So now you have an array of paragraphs, okay? And what you can do here, let's see here, by index, yes. So this is getting the paragraphs .0.inner HTML, and what this would actually return. So obviously paragraphs is your array at index 0, which is the first one. .inner HTML would actually be this isn't really correct here. Yeah. It is. I think it's a little confusing, but that's okay. But yeah, you're getting it by index. So you're getting this paragraphs. I apologize. You're getting paragraphs by index 0, which is this one. And then you're getting the inner HTML. So this is going to return, basically, if you print this out, this is going to return welcome, right? Here, you've got paragraphs, right? And then you can do .hours, which is the ID, .inner HTML. And so this would write, document.write, open daily. Okay. And this is just getting you the total count, which would be 2. Searching through the DOM. JavaScript provides several methods for retrieving HTML collections based on different criteria. Get element by tag name. That's the one we already looked at up here. Get element by tag name for the paragraphs, right? And this is it's got to be a legitimate, right? A true tag that's part of the HTML specification, obviously, right? Either a paragraph or like a list item or image, a div, right? It has to be a valid tag name. Also, you can get elements by class name. So if you have a class name, you have certain ones that you might have a class on, and you want to grab all the ones that have that class, then you can do that by class name. Get elements by name, the specific name attribute value, right? That's the name attribute. Sometimes, a little confusing. Make sure by name sometimes could be confused with the tag name or something. It's different, right? It's using the name attribute, whatever's the name attribute. So if you've got one with the name attribute, you can get them all by that. So these methods here can be called on a specific element reference rather than on the whole document, narrowing the search to elements nested within one branch of the page. Okay, so here we've got one where, let's see, we're grabbing it, get element by ID. In this case here, we're grabbing the menu, right? And then we set that to, we got a variable, so we're doing document.get element by ID for menu. So now this holds on to that menu object, this complete object, right? Including everything in it, okay? That's what menu section is. Now, menu section, now you can take that menu section and get elements by class name, bread item, okay? And then that would return this one, okay? Get elements, I'm sorry. This is actually going to be an array, right? Each bread item has two, right? So basically like this is getting, this is still, this is kind of like getting that specific object. It's getting this whole one, right? When you do get element by ID, it's always going to kind of be one, right? So you're getting this whole chunk of code, so to speak, right? By doing get element by ID. Then when you go ahead and grab get elements by class name of bread item, right? This is going to be an array of bread items. So this will be both of these. Viewing arrays and collections in the console. The browser console is a useful tool for inspecting the current context of an array or HTML collection while a script runs. Logging a value to the console displays an expandable view of its contents, including its length and every element's index and value without writing anything to the visible page. So, so you can use console.log in your code. Okay, we'll be taking a look at this so that you can, you can view this in the console like in developer tools, right? But you don't see it in the code. A user that doesn't know would not see it on the page, right? The console's only going to write it. This console.log is only going to write it to the console, and for somebody to look at that, they'd have to understand the developer tools, right? But here it's just saying, if you do console.log on weekdays, it's going to show you the full array in the console, right? And then if you do weekdays.length, it's just going to display the number 7. Okay. So logging an array or collection to the console is one of the fastest ways to confirm that the data is loaded or built correctly, especially before adding the more complex logic that will process it. Working with program loops. So that's all we're going to kind of cover right here in the guide on that. Now we're going to kind of look at processing data, right? Working with program loops. So a program loop is a command block that executes repeatedly until a stopping condition is met. Each repetition of the loop's command block is called an iteration. Okay, the while loop. The while loop is a pretest loop. Its condition is checked before each iteration runs. If the condition evaluates to a falsy value the very first time, the command block never executes at all. So first you check the condition. If the condition is true, you're going to go ahead and execute whatever within the curly braces here. If it's false, you will not. Right? Okay. So, and here's an example where you're setting a counter equal to 0. And then you're checking if that count is less than 5, right? So it starts at 0, and usually you always start at 0 for counters. You know, there can be some times you want to just start at the other, but arrays are kind of already set up as 0 base, so you really should always do that, right? So less than 5 is going to be 0, 1, 2, 3, 4. Less than 5 will be 5 because you're 0 based, right? So you're checking if it's less than 5. You're going to be you're doing a document.write, right? And printing out the tray count. Then after that, we're doing a increment, right? A post increment. If you recall, post increment, a pre increment, you'll have pluses at the beginning, right? You're gonna add before, but you want, in most cases, you're gonna be doing post increments, right? There are some variants. We'll take another look at that later. We've already looked at that how the variable gets set a little differently based if it's a pre-increment or post-increment, right? In most cases, you do post-increments, but there's times you might need to do a pre-increment. But this is a post-increment, so once again, though, like it says here, this loop will never end without this. So if you forget to put this and you have something like this, tray count's always going to be 0, and it's just going to keep on looping through this pretty much. And especially within a browser, it's going to, it can run long enough. It's going to actually eat up all your memory, and it can kind of mess up things, right? A lot of times, modern browsers actually tell you, this something's going on around here. You sure you want to continue, right? To kind of prevent problems like that. But earlier days, yeah, you do something like this, and sooner or later the browser would just crash because it'd be an endless loop, right? So a counter is a variable inside the loop's command block whose value changes with each iteration, typically by incrementing or decrementing. Okay, an infinite loop occurs when the stopping condition never becomes false, right? Often because the counter is missing or updated incorrectly. So always confirm that a while loop's command block contains a statement and eventually makes the condition false. Right? Forgetting to update the counter is the single most common cause of an infinite loop. Okay, now let's look at the do while loop. A do while loop is a post test loop. Okay, the command block executes first, right? The condition is checked afterward. This guarantees the command block runs at least once, even if the condition would have been false from the very start. Okay. So basically, here's a do while, and so this gets done no matter what. Okay. And then we'll continue until this condition is met, or until this is false, I should say, until this is false, right? So here in this case, you got an order number equals 1, right? So this would obviously be, sometimes I said that, a lot of times, especially with an array and stuff, but there's certain other things that, you're going to set at a positive number, like, like a 1 or whatever. Like order number, you can't have a 0 order number, so, it kind of makes sense here, right? Order number is 1. Processing order number, right? So what's going to happen here on a do while, it's going to go ahead and write this, right? As long as, it's going to write this no matter what this was, right? If you could start this at the number 50, the order number could be 50, right? It does not pass this test. This is going to return falsy for a 50, right? But since it always executes once, this is going to get executed no matter what. And once again, it's important, to once again, this could still be a infinite loop if you don't increment, right? So here you're going to do less than or equal to 3, right? Come in the first time, it's going to be a 1. So you want to do this and process over there as long as it's less than or equal to 3. So pre-test versus post-test. Pre-test condition checks first, right? Command block may run 0 times. So this is just the typical while loop, right? While or for, right? Best when loop should only run if the condition already holds. And in a lot of cases, this is, this happens more often than the post test. But this can also be true as, there are many instances where you do the post test as well, right? So the command block runs first, always executes at least once, best when an action must happen before its result can even be checked. Now let's look at the for loop. So the for loop combines a counter's initialization, its stopping condition, and its update step into a single line, making it the most compact and most commonly used loop for counting through a known range of values. Okay, so here you've got here's your for loop. Obviously, open and close parentheses for for loop, and then obviously the curly braces. And then the first part of it's going to be the initialization. The second is your condition, right? And then basically your update is going to be, you're incrementing or decrementing a variable, right? So here's an example where you're starting with a value of 0. As long as I is less than 5, right, is your condition. So it's going to continue to run, right? And then you are doing a post increment, right, of I. And here we're printing out I each loop. So compared to a while loop, a for loop keeps the counter setup, test, and update together in one place. It's all together in one place, right? Whereas for your while loop, let's look at the beginning while loop. This is where you're doing your initialization. This is where you're doing your condition. This is where you're doing your increment or decrement, right? So it's kind of 3 different places. Where for your for loop, it's basically all together in one, right? So let's see, which makes the loop's behavior easier to read at a glance and harder to accidentally write an infinite loop. Very true. Nested for loops. So a for loop can be nested inside another for loop to iterate through 2 separate counters at once, which is useful working with multi-dimensional arrays or generating grid-based output. Okay. So we have our display case here, right, which is a multi-dimensional array. Then we're doing a for on our display case shelf. So basically our outer, right, our outer array, and then our inner, and then we have to loop through our inner array in this case, right? Very common to use dot lengths for especially arrays, right? For arrays, you're usually going to know a value coming in, how big the array is, and so using a length is very popular, very well used as far as the condition is concerned. Iterating through arrays and HTML collections. A for loop is a common way to step through every element in an array or HTML collection, since both expose a length property that can serve as a loop stopping condition. Okay. The insert adjacent HTML element. So an insert adjacent HTML element adds a new HTML content next to an existing element without replacing the element's current content, which is useful inside a loop that is building up a list or a table one item at a time. Okay. So here is the syntax: insert adjacent, and you have a position and then the HTML string. We look at an example here. So here we've got our menu items, right? And we have our menu list, which is right here is in our IDs, our HTML, our unordered list is your menu list is going to be your unordered list here, right? Menu items is your array of 3 items. So you're looping through your menu items, your array. Okay. So what you can do is, with JavaScript, obviously you put you can really manipulate you can add things, you can remove things from your HTML DOM, right? That's what you're kind of doing here. You're dynamically adding, or in this case, we're adding things, right? You can also remove things as well. So we're adding additional ones, right? So we're adding this whole list, right? And what we're doing here on this one is we're going to do taking our menu list, insert adjacent HTML, right? And in this, we're adding a list item, okay? We're adding a list item. We do this before end, right? The position before end, right? And then the second part is going to be our HTML string, which is going to be the list item, right? And then the menu item. So we're looping through and adding this for everything in our menu items, right? Every single one is going to have a beginning and end li tag, right? Inside of our unordered list. Okay, our position values, the different ones. In this case, we did the before end. There's other ones as well. You can do just before the target element, right before it. After begin, just inside the target element before its first child. Okay. And that makes sense when sometimes we only have one here, but you could have a complex HTML thing and you want to make sure it's in the right place, right? And if you let's say you already had list items here, well, you want to make sure you put it in the right spot, right? So after begin is going to be just inside the target element before its first child, okay, if it already had a child, right? Before end, just inside the target element after its last child, right? So if you already had multiple ones already in here, list items, and you want it to be the last one, then you would go ahead and use the before end, right? And then you may want to include something after the end tag of something, right? After the end tag. So you use the after end in that case. Exploring array methods for generating loops. So JavaScript provides built-in array methods that perform many common looping tasks more concisely than a manual written loop. These methods accept a callback function. Okay, a callback function, a function passed as a parameter to another function or method. Okay, so that's important to understand, right? A callback function is a function passed as a parameter to another function or method, which is automatically called once for every element in the array. Okay. So here is the syntax. You got the array name dot method name, right? And then here's your callback function. Okay, it runs every time and for every element in an array name. The for each method. The for each method applies a callback function to every element in an array in order, right? It does not return a new array. It simply runs the callback once per element, much like a for loop, but without needing to manage a counter or stopping condition manually. Okay? So you don't have to for each, you're just looping through this, calling something on it until you're done, right? Until you've pretty much exhausted that whole array, right? You don't have to control it like you do for a for loop, right, or a while loop. You'd have to control that, right? So all of these, the same thing we're doing here for each, you can still do in a for loop or a while loop. This just makes things a little easier, right? So here you've got your menu items, your 3 menu items, and then what you're doing here is menu item for each. You're doing a for each on your menu items, right? And then you're calling, this is a name that you're giving this, right? So this is basically, what this will do here is it's basically taking each item, right? Item is each of these in your array, right? This is a name that you give it, whatever programmer name that you're giving it, right? You can call this whatever you want. But in this case, you call it an item, right? So this knows when you do a for each, it knows that whatever's in here, right, is basically each one, right? And you call it an item, and in this case, you're just writing it out. And then also after that, you're putting a break, all right? So different array methods. So the purpose. So for each runs a callback once for every element, does not build a new array. Map. A map builds and returns a new array containing the callback's return value for each element. A filter. So a filter builds and returns new array containing only elements where the callback returns true. Okay. Find returns the first element where the callback returns true or undefined if none match. Reduce combines every element into a single accumulated result, such as a sum or total. Okay, so let's look at this. We've got a array of daily sales, right? This is an array, literal, right? And then we're running this map on here. So on our daily sales, we're going to map. We're calling this a function, right? And we're taking the amount, right? Which is each one of these, right? This is a name that we're giving it. So that amount is each one of these as it's, right? And then we are returning that amount times 2 into this variable, right? The important thing is map builds a new array with each value doubled, okay? It does not replace daily sales, right? It's going to create a new array, right, of these, and they're going to be multiplied by 2, right? Each one. Now, filter keeps only days with the sales above 50 in this case, right? So what this is doing is yeah. So what you're doing is you're creating a new array called strong days, right? And then what this is going to do is it's going to filter the array. It's going to take your existing array. It's going to take this existing array, and it's going to create a new array with any amount that's greater than 50, right? So in this case, it's going to be an array. Strong days will be an array of 2 items, right? One of 58 and one of 67 because they're greater than 50, right? And where this comes in handy, especially when you've got large data sets, a lot of data, where you don't necessarily want to kind of be iterating on it. You want to reduce that down to something that's more manageable, or things that you're wanting to display things. Let's say you've got a web page that you have different drop downs where you choose different things, right, on that drop down because you want to display different things based on that. So that would be a good use of a filter, right, where it depends on what they chose in that drop down. It's going to filter on that item, and then you just create a new array for that selection that you made. So array methods that take a callback function are generally easier to read than equivalent manual loops, since the method name itself, filter, map, find, describes the intent of the operation, right? For very large arrays processed many times, a traditional loop can sometimes run faster. So consider performance needs for large scale or repeated operations. Okay. So yeah, traditional loops do run very, very quick, much faster. Okay. this has to kind of do a little bit more because you got the callback function and stuff like that, right? But as far as for an understanding and simplicity, these different array methods are very handy. Adding decision making to your code. So decision making is a process of choosing which code to execute in response to a circumstance. A decision-making statement, also called a decision-making structure or conditional statement, right, is a special category of JavaScript statements used to make these choices. The most common is the if statement. So an if statement executes its command block only when its condition evaluates to a truthy value. If the condition is falsy, the block is skipped entirely. Okay. And then here, obviously, for an if statement, you're going to do whatever, you're going to be using the parentheses and then your curly braces as well. If it's a simple one, you can do it on, one line or skip the curly braces. But, traditionally, and I usually always include the curly braces. The important thing is to be consistent. So here we got a loaf count of 3, right? And if the loaf count is greater than 0, write that out, right? Which is only going to execute that one time. Depends on if it's in a loop or whatever. It's just this showing a simple little statement here. The if-else statement. So if condition, you're going to do that. If it's truthy, you do that. Else, you do that, right? Pretty straightforward there. So here's an example. Loaf count is equal to 0. So if it's greater than 0, you're going to go ahead and do this. Else, you're going to write this out. The else if statement. When a decision involves more than 2 possible outcomes, one or more else if clauses can be chained between the initial if and the final else. Each condition is tested in order, and only the command block belonging to the first condition, the first true condition, runs, right? So if this, right, runs if condition 1 is truthy. So if condition 1 is truthy, right, it's going to enter this code, right? If this, then you execute what's in here. Else, if this, then you execute what's in here. Else for everything else goes in here, right? This is just kind of like a little shortcut. When you got multiple things, you do else ifs. So basically, if this condition is true, you're going to do that. Then if it's not, then you're going to check another condition, all right? And if that's true, you're going to do this. And in this case, you do. If it doesn't, if neither one of these conditions are met, right, then you're going to run this. So in this case, if loaf count is equal to 0, it's sold out, right? Else if it's less than 5, it's low on stock. Okay, if neither one of those conditions are true, basically truthy values, then you're going to drop down to the else statement here. Nested if and else statements. Okay. A nested decision-making structure places one decision-making statement inside the command block of another, creating a series of conditions that must all be true before the innermost code runs. Okay. So here we got is members true, order total is 42. So the first thing is, the important thing is to see where your beginning and ending curly braces are, right? So basically here, right, let's see. A lot of times you look on the inside, you can tell that that belongs together. This belongs to that else, right? This if, obviously it helps when you're, indenting correctly, right? So this if member here is ended here, right? So basically, if is member is a falsy value, is false, right? It's going to drop down here and you're done, right? It's going to tell you to join because you're not a member, okay? If you are a member, it's going to go ahead and come to this next statement here. It's going to check if the order total is greater than 25, okay? If it is, then it's going to write this, else it's going to write this, right? So if is member is a truthy value, it is going to execute this, and you're going to have one of these others, right? Else you're going to, if you're not a member, you're going to be here. So, but no matter what, in all of these cases, you're basically only going to have one document, only one line written, right? If it's not a member, if is member is falsy, it's going to print out this. If the member is true, it's not going to come in here and check any of these. It's not going to check anything on here unless this is true. Once it is true, then it's going to go ahead and execute this. And then order total, depending on what order total is, in this case, right, it's greater than or equal to 25, so it's going to print out this. Okay, browser testing with conditional statements. A browser test is an if-else structure that checks whether a specific JavaScript object, property, or method is supported by the user's current browser, then runs the appropriate code path for that situation. Okay. So this is using the built-in browser geolocation. Okay, and this is part of the browser, right? This is part of the BOM, really not the DOM, right? The browser. So this is using the navigator object as part of the browser, right? And checking for the geolocation, right? The browser supports geolocation, use it. So it's going to check to get the current position, right? Get the current position of geolocation, okay? Else, here's the fallback for browsers without geolocation support. It's going to write this out. And this is just a simple if-else. So browser tests are valuable when a feature support varies across browsers. As features become universally supported over time, its associated browser tests can usually be safely removed from the code. All right, so we looked at the while loops. We looked at for each. We looked at some of those array methods such as filter and map, right? And then we also looked at different if-else statements. Okay, and now we're going to go ahead and look at the switch statement. So a switch statement compares a single expression against a series of possible case labels, running the statements that follow which label matches. It is often a cleaner alternative to a long chain of else if statements when checking one value against many specific possibilities. So here's the basic syntax. You have your expression of your switch statement, okay? Open and close curly braces, and then you have your different cases, okay? If this expression equals this case value, right, then it's going to run this, okay? And then it's going to, in this is the basic way to do this, and then it's going to break out of this loop. It's not going to check any of the other cases, okay? If, if this is true. Then if this was not true, if this value was not equal to this expression, this would not run, right? And it would go check the next case. If this one if this expression equals this value 2, right? It would run whatever's here and then break out, okay? And then if not, if the different cases didn't match the expression, it's going to come down here to the default. You always have a default here, right? And then all of these, whenever you do the cases and the default, you always use a colon, right? A colon. And then so the default is if it didn't match either one of them, then you're going to go ahead and execute this. That's in the default area here, right? So here's an example here where we've got order status of baking. Okay, so we're going to come in here. Order status is baking. We're doing a switch on this expression, right? We already know it's baking. And it's always in your code. These things can be generated. You don't know necessarily what the value is going to be, right? Because it could be different in different scenarios. But in this example, we know that the order status is baking. So order status here, the case is received. Nope, that's not going to do that, right? It's going to check the next case. Is this baking? Is this case equal to this expression? Yes, it is, right? It's going to write this out, okay? And it's going to break. Okay. So if for some reason this order status was something other than received, baking, or ready, right? Then it would drop down to this default and it would print out this. And then obviously the important thing, is the break, right? Without the break, it's going to read the next line, right? Even if it's not going to execute it. So in this case, you had baking. So obviously the first one, even if you didn't have break here, right, it wouldn't matter in this case. But if it's not received, then it's going to go down to go down to baking, right? And then if you didn't have this break here, right, it would obviously print this because this matches the expression. Matches the case here. It would print out this. If you'd omitted this break, it would actually go down here. It would check the next one, okay? And then it would check this one. It would not match, right? So it would not match. So it would go down here to the default and print out status unknown, okay? And that's like I'm saying, if you forgot to put this break here, right? So if you forgot to put the break there, it would print out this line and it would just continue down this list, checking cases, right? So it would end up printing out this line and it would end up printing out this line. So that would happen if you forgot to put the break here. Okay. Fall through occurs when a break statement is intentionally left out of a case. So sometimes you do want to leave it out, okay? We're going to take a look here. Allowing execution to continue, moving through the remaining case labels until a break is reached or the switch ends. So that's an important way to understand it is, it's going to continue until either it has a break or it basically goes through everything and reaches that default one, right? So in some cases, you may have multiple labels that will, multiple cases that you want it to match, right? And in this case, you've got day abbreviation being Saturday. That's what your expression is, right? And you're going to be checking that. This is your expression. This is your variable, right? Your expression is your day abbreviation, which we know is Saturday. So basically, if this is Saturday or Sunday, right? So this is basically saying if it's this one or this one, then go ahead and do document.write on this one. And it's telling you the weekend hours and then it's breaking, right? So in this case, there was a reason to skip the default, right? You could write this twice, right? But this is a little less coding, right? A little less to write here. So basically you want this to happen if either one of these, then you're going to break out of it, right? So basically this is what you do for the weekend. If it's not the weekend, your default is your weekday hours. So once again, omitting a break statement by accident rather than intentionally for fall through is a common source of bugs. Always include a comment when fall through is deliberate, right? Sometimes you want to fall through to the next thing, right? So future readers know it was not a mistake. Obviously, this one here is pretty obvious. Why? Because it's a weekend thing. It makes sense, right? But sometimes in your code, things may be a little more complex than that, and you need to explain a little bit, so you want to make sure you comment that. Managing loops and conditional statements. All right. the break statement. So we just looked at the break statement for the switch, but it can be used in other places as well. So a break statement immediately ends the loop or switch statement it appears in, skipping any remaining iterations or case labels. Okay. Inside a loop, using a break, as soon as a search target is found, avoids unnecessary iterations through the rest of the array, which improves performance for large data sets. Okay. So we've got 4 menu items here, right? We're setting found equal to false. We're looping through this using our traditional for loop. We're checking for the menu item. All right. The menu item equals the menu type, in this case, sourdough. We have a found equals true, and then we're going to go ahead and break it. Okay. Obviously, something as short as this, you've only got 4 items, but if you've got something that's much more substantial than that, you have an array of 50, 100, 1,000 items. You don't run and continue looping through your code, right? Once you find the item. So you start at the beginning, right? There's no reason, if it's the 3rd item in a list and you got 1,000, no reason to keep on looping, right? You've already found what you needed, right? The condition has already been met. Then you just want to go ahead and, usually you set something like found to true, that's kind of common, or, whatever you call it. And then breaking out, right? So this will break out of that loop. The continue statement. So the continue statement skips the rest of the current iteration and moves directly to the loop's next iteration without ending the loop entirely. Okay, this differs from a break, which exits the loop completely. Right, we just looked at one and it'll exit completely, right? And so in this example, we just got some fake data here where we got some undefined stuff. And then we're looping through this, right? And then so basically what's going on here is you really want to process all your orders, right? But if in this case, if this quantity, for some reason this quantity is undefined, right? Then we want to just kind of go to the next iteration. So that's what we're doing here, right? We're not breaking out of the loop. We're just stopping. We're not going to execute this line. Okay? We're not going to execute this line if the order quantities is undefined. We just want to go to the next iteration. That's what we're doing here, right? Without this continue, it's just going to continue on, right? Or I shouldn't say continue on. It's going to go here and print this, right? In this case, you just want to go to the next iteration. So a break basically exits the loop completely, where continue just goes to the next iteration. Okay. Like I just said, there we go. Okay, statement labels. So a statement label is an identifier attached to a statement, often a loop, allowing that statement to be referenced elsewhere in the program, typically by a break or continue command targeting an outer loop from within a nested inner loop. Okay. So yeah, the statement labels are really good if you got some complex nested type iterating, different iterations going on, so you can kind of break out. Okay, so let's go ahead and look at that. So here you got a for loop, and you're using the label shelf search for this for loop, right? And inside that you got a nested for. And so you're iterating through this for loop, and if the display case shelf item is right, you want to break out of this, right? So what you're doing is, because if you just had a break here, right? If you just had a break without this, right? This is only going to break out of this for loop, right? to break out. So sometimes you've got a outer loop and an inner loop, and you, in this case, you want to exit. Well, you're exiting both loops at once. And usually this is the case where you want to exit that outer loop as well, right? Not just that inner loop. If you just had a break without using the label here for the outer loop, it's just going to break out of this inner loop and then go to the next iteration of this for, right? In this case, the way this is coded using the label here, you're breaking out of both this for loop and this for loop. So statement labels are powerful but easy to overuse. Code that jumps frequently between labeled sections become, spaghetti code, convoluted logic that is difficult to trace line by line. Reach for labels only when a nested loop genuinely needs to exit multiple levels at once, and prefer structuring the code, such as moving logic into a function with a return statement when possible. Okay. So let's go ahead and review some of the things we've talked about a lot here. Arrays and HTML collections, loops, and different array methods, decision structures, flow control, many different pieces here, right? So let's go ahead and do a quick review. An array literal, basically that's when you just define a variable, you use the brackets, and you put your values in the bracket. And these can be any kind of data type, any allowed data type, and they don't necessarily have to be the same. You could have a number, and then a string, and then a Boolean, right? And this is very loose, right? Very loosely, as far as opposed to some other programming languages, it's that you have to state the exact type of your array. With JavaScript, it's very loose, and you can mix and match or whatever. In most cases, that's not always the best. There may be some certain circumstances where you have that, but for the most part, you're going to have the same types, right? But JavaScript does allow you to just stick anything in an array. You don't have to explicitly state what kind of type it is. Index is the numeric position of the n element. Okay, always starts with a 0. Length property, total number of elements, including undefined gaps. Remember, we looked at those undefined gaps. If you had an array at position 0, you defined a new array, and you said this array at position 0 is this value, and then the next line under that, you have that array at a position, say, 5 or 6. Anything in between there is going to have some gaps, right? So it's going to actually, that length property is going to still create those spots in memory, even though you didn't give them a value, right? You didn't assign a value. Multi-dimension array is an array of arrays used for grid-like data. HTML collection. It's an array-like group of same type elements, right? Updates live with the page, right? So you can automatically choose something on a page, click a button, a radio button, a check box, something from a select box, etc. And you could click on that, and then the JavaScript can actually remove elements, add elements, do all kinds of things, right? And that happens kind of in real time live on your page. A while loop. A while loop is a pre-test loop, right? The condition checked before each iteration, right? Nothing will execute in that while loop unless that original condition is met. A do while loop is called a post-test loop, right? A command block that runs at least once. So a do while loop always is going to execute once, right, before the condition is checked. A for loop. That combines your initialization, your condition, right, and your update, usually what's an increment or a decrement, right, in one line. For each and friends. Array methods using callback functions to replace manual loops, right? So we've seen that with, like filter and, filter and map, etc. Right? So it's always going to call that callback function. You don't have to worry about your indexes, what you're at, right? It works better with some kinds of arrays than others. For JavaScript, pretty much it works very well with JavaScript. Some other programming languages also have it, but it's not always the best case. But for each, the important thing was really for each, you don't have to worry so much about getting in endless loops, right? It's just going to loop through all your elements of your array, right? And it works very well when you want to perform some task on that array, not just printing out values, right? Usually you're doing something like for a filter or a map, etc. So the if else, and else if, right? Core decision making structures for the branching logic. Switch statement compares one expression against multiple case labels. And the other thing important for that is, you want to make sure you got your breaks in the right places so it breaks out of that. And also, you have to always have that default at the end as well, which is your fall through, right? Omitting break intentionally to share code across case labels. Okay. Omitting break intentionally. So sometimes, like I mentioned, on the example we looked at, where you had a Saturday and Sunday, you want something to execute if it's a Saturday or a Sunday. So usually that's the case when you got ors, where you're thinking, I want if this or this, then you can loop them. You put those together. You don't put a break after each one because you want it to be if any of those are true, you want to do some specific thing. And that's where you go ahead and omit the break intentionally. Break exits loop or switch statement immediately. Continue. So continue skips the next iteration without ending the loop. Then the statement label names a loop, so break can continue can target it from a nested loop, right? Okay. So that's all I have on this guide. And next we'll go ahead and look at the demo. Okay, I have a demo for you and we'll take a look at that now. All right, so in this demo, we've got we're going to start with arrays here, array literals and indexes. So we have this button called Inspect Raster Array, right? It holds 5 game names, and then it's just going to print them out, right? Pretty basic here. Let me just run this, make this a little bigger maybe. And then here's the full roster, right? Galactic Blaster, Turbo Drift, Shadow Maze, Neon Fighter, Pixel Quest. Just the 5, basically an array. Okay, so let's look at how this was executed. So basically we've got a button, this button right here is inspect the roster array. And then if I can go ahead and sometimes this works for me and sometimes it don't. And we'll go ahead and go to the definition. And so here is the function for this. So basically it's just getting the length of the game roster. So where's that game roster at? Let's go to that definition. So here's your game roster. And these are the ones that were printed out. So they're just a basic array literal, right? Most common way to create an array, just values listed inside square brackets, right? Separated by commas. And so then we're just taking and looping through the basically just looping through the whole array, right? And printing those all out. And then in this case, what we're taking is our output. So we have this array, kind of this output thing that's kind of being used for multiple things here. Basically, it's getting that element by ID, right? Using the text content, right? and then assigning the info to that, right? To that variable, to your text content, which is everything that's basically up here, right? So just a basic array there. Let's see, what was the next one here? Read element. So you're going to select which one here. And then it's just grabbing. So in this case, it that one was the, let's make sure I grab the right one here. Replace by index. No, read by index. So let's go look at that. This is basically getting the value. It's doing, and it's doing a parse int because you want the value, right? That's in your select statement here, right? And so you're grabbing that value, right? And setting that to an index, right? And then guard against out of bounds indexes. Yeah. So this is just doing an if statement just to make sure that your index is a good index. It's not a number, you know, it's not something other than a number, right? Just being careful about that, right? It's just getting that. And then basically there it's setting the text content, right? So that text content is once again this area right here. And it's basically, you know, printing out game roster, your index number, right? And then getting it out of the array, right, at position 1. Okay. Next one here is the replace with coin op. Let's look at that one. Replace by index. Let's go to the definition for that one, right? So we're getting the element. So it's using the same one, right? Getting element input value. So I chose number 2, index 2, right? Then what it's doing is it's grabbing the array, right? It's grabbing that game roster array, and it is setting that a value with a new one. So you're getting your old value, you get your index. So in this case, game roster at index 2, right, was Shadow Maze, right? And then you're taking, so that's your old value, right? And that's why we're getting the old value just so we can print that out. But then we're going to change that, and we're just taking that index and assigning that a new value, right? Pretty straightforward. Then obviously, once again, to put these things in this area here, we're using the text content. Okay, let's use build and inspect parse array. Okay, let's go look at that one. So this has a number of tickets, right? It's putting this value, an empty array, right? And then it's using at index 0, signing at 101, at index 5, signing at 106. It's the same thing we looked at in the guide. But what happens here is what's going to happen behind the scenes is JavaScript it's actually going to allocate memory locations for in that array for 0 all the way through 5. Okay, 1 through 4 will be undefined, right? But they still will be there. There will be a place allocated in memory for them. And that's the important thing. So if you ever skip them in JavaScript, it will go ahead and take care of that for you. All right, but they will be undefined in other areas. So, so it's just showing ticket 0 at 0 was here 101, so that has a value. Ticket 1 is undefined, right? Never been assigned. Obviously, if you checked for 2, 3, 4 as well, it'd be the same thing, right? Tickets at 5 is the 106, right? And then as far as getting the length, since you started at 0, right? 0 through 5 is 6 items. The length will be 6 because 6 places have been allocated in memory, right? For that array. All right. So now let's look at this inspect 2D array. So arcade cabinets. Let's look at that. So here's our 2D array, right? Which each one has 3 items. There's just some spacing here. So each one of them has 3 items. Well, not, I shouldn't say that. They have 4 items each. Each one has four different items, right? So this is the array at arcade cabinets 0, 0, right? 0 would be this row, right? And then this would be at arcade cabinets 0, 0. This would be 0, 1, right? And this would be 0, 2. So let's go ahead and click that. So cabinets at 0, 0 is going to be a galactic blaster, right? Row A, column 0, right? Rows and columns. So this is the row, right? And this is the column. Row A, column 0, and then arcade cabinets at 1, 2, right? So it's going to be, this was 0, this is 1 here, and then you're going to do 2. 0, 1, 2 will be retro. And then the other one was at arcade cabinets 2, so this is obviously 0, this is 1, this is 2. So at row C, right? The third one, which is number 2 as far as from a array standpoint. So this one, and then at column 1 is going to be, this would be 0, and then 1 would be grid runner. If you check, obviously, if you check the length of your arcade cabinets, length, right? It's going to be 3, right? 1, 2, 3. If you check the length at arcade cabinet 0, right? If you don't put any subscript, right? Index, you don't have a subscript there. Length, you're getting this value, the length of how many of these, right? If you do arcade cabinet 0, right? In this case over here on the right, arcade cabinet 0, it's basically getting the length of what's in here, right? Which in this case is 1, 2, 3 items. These other ones had, they all had 3. I was saying 4 earlier. They all had 3, right? So if you actually had more than that, it's going to, if you put another one in here, it would print out 4, right? And it's just showing you the full grid, right? For each one at 0. So at row 0, column 1 through, the first one through the third one, right, is going to be that very first row. Here's your second row, and here's your third row. Pretty straightforward there. Okay. Let's look at our HTML collections now. So the boxes below are div elements with the class game card. JavaScript can grab them all at once as a live collection. Get by class name. Okay, so we've got, let's look at these. We've got a game card. We've got game card, and a couple of them have featured card, right? A couple more have featured card as well. These are just game card only, but if you grab by game card, it's going to grab all of the game cards, right? All four of these. So let's go ahead and take a look at that. So cards equal document, get elements by class name, game card. So you can get all of those. Pretty straightforward here on that. One, two, three, four, five. Was I wrong on the number here? Okay, let's look at this again. One, two, three, four, five. Yeah, okay, there's five of them. So all five of these. So here's each one of those. Card Galactic, right? Card Turbo, Card Shadow, Card Neon, Card Pixel, right? So it's each one of those. We also can get it by tag name, right? So here we're just grabbing get element by ID cabinet wall. And let's click on that. Get element by tag name div. Scoped to cabinet wall. Let's look at that a little better here. We get the element by tag name. Okay, so yeah, so we're getting the div, which is the cabinet wall. Let's go back and look at that. So cabinet wall is the div. So we're basically getting this object and everything in it, right? We're getting this HTML element and everything in it by ID. So we grab the cabinet wall, right? So then we have an array of divs inside of that, right? Inside of our cabinet wall, we have an array of divs, including anything in here and everything. So it's basically the whole object, and this object, cabinet wall is an object, the div ID, a div object, and on the inside of that, it has an array of divs inside of it, right? And then in this case, we were doing what? So we get all five. So what we're doing here was a get length of 5. So we're getting all of the array of elements that are the different divs that are in there, and that has a length of 5. Let me go back to that real quick here. Which was which one? Get element by tag name. So once again, wall. So you got a variable, you're calling it wall. You're getting the element by cabinet wall, which is basically that parent ID that contains those other divs. Then you're creating a new variable called divs, right? You're taking your wall, which is the cabinet wall. So you take that ID, right? You're just grabbing a piece of your HTML. So you're grabbing a piece of your HTML, which is that get element by ID cabinet wall that's holding on. It has an array of your divs there, 5 different divs, right? And then you're grabbing that, right? And then you're printing out your length, right? Printing out your length, collection of items, right? And we add highlight it. The arrows are searched to just that element's children. Okay, yep. Okay. All right, so let's get scope search. Let's look at that one. So once again, you're getting your object, which is your HTML collection, which is the cabinet wall, which is the div. Then you're getting elements by class name feature card. So let's go look at that. So here you've got a class called feature card here and here, right? Some of these others are not, right? This doesn't have featured cards, so it's not going to grab those. So we're just getting those. In this case, we're grabbing Galactic Blaster, which is a featured card, and Shadow Maze, which is another featured card. Okay, reset cards. All right. And we might as well look at the reset, huh? So in this case, you're kind of, I know we did like resets on forms a little bit there and stuff, but it's kind of a little different here. You're having to kind of remove some items. So in this case, we added a highlighted item. We need to remove that, right? So we just kind of get that, reset everything is basically what we're doing here, right? And this is just displaying what we wanted to display. So we're getting the game cards and we're moving the highlighted item that we created dynamically, right? Okay, next let's go ahead and look at some console logging. All right, let's go to this console logging here. So let's see what we're doing. So we got the log game roster. And we're just doing some basic game logs, right? Here where you can, with a log statement, you put the name, right? And then put a variable, right? So here you're doing an array. Basically, you're saying, give me the whole array. So it's going to log the whole array. This one's here, so it's just going to give you the length, right? So let's go ahead and click that. Let's see what else here. Okay. And this is just showing you some stuff down in here as well. That's all this is doing. But we want to look at it in Chrome Developer Tools here. So I'm going to go ahead and do this, and I'm going to go ahead and click on Log Game Roster. Oh, let me just make this big. So I'm going to do an F12 here. So I've got my console showing, right? And obviously, kind of like I mentioned before, you kind of got to, depends on what you did last. It kind of remembers where you are in the developer tools. So you might have to play around, make sure you get to the console, right? So once there, I don't know why that kind of gets stuck there a little bit. Okay, so I'm going to click on that game roster. That's where that did those log statements. And I'm going to drop them right here in the console, right? So this doesn't happen. These things don't display on the web page, right? This is only within developer tools. This is for debugging purposes, right? For debugging purposes for the developer. So I'm going to click on log game roster here. And as you can see, it went ahead and printed out your array, right? And then also it printed out the length, right? It had two console logs, one for, actually, it's still kind of, it puts length there by default. But, so this is your array, right? And then this was that second one that just did the length, right? And length of 5. Okay, let's click on log leaderboard. And so this is just printing out that. So maybe we should we'll look at that code a little bit. Let's just do this other one since we're already here, and then we're going to log the arcade cabinets. So this is that multi-array, right? Multi-dimensional array. Okay. So really the important thing is just to realize that, how to do log statements, right? Where they're going to go. And I will show you something else here. Let me show you something else real quick too. Let me get this back to where it was. So as you kind of notice, we had like console.log here, right? That's the basic way to do it. But there's other options available too. And this is kind of more from a developer and testing and debugging standpoint. There's other options here. Okay, so here I'm going to do. So I've got console.log. I'm going to do console.info. Okay, this is another option. So let me show you that. I'm going to save that. Let me get back to my other screen here. Now in here, and also remember anything you do here, especially when these click buttons and these things are getting put in the console, like once I make a change, so I just made a change and I changed log to info, it's going to refresh the whole page. So anything that kind of got put in here, it's going to refresh, right? So it kind of starts over, right? Same thing as if you click refresh, right? This is one way to reload the page, or even F5. F5 is another way, right? Hit F5, it's basically going to refresh your page, right? Just to keep that in mind. Now, up here in the console, you got these different default levels, right? So all of these are marked. So by default, this is what's by default. Let's see what's by default. Is it all of them? Yeah. Well, verbose is like, let's just say you've got something you're trying to research, diagnose some issue you're having, debug some issue, and you just start putting a whole bunch of statements in there, right? Well, you can put those in on using verbose so they don't always show. So they're not always going to, because there is some, this stuff, even though, because all of these statements that you put in here for consoles are going to always be there for everyone, right? Even though a lot of people don't even know how to get there and stuff, it's still writing that stuff out. There's still some resources that are used to do that, right? For performance and stuff like that, right? So you sometimes don't want to necessarily fill up this log with a whole bunch of stuff you don't need to, right? So you got to think about that. So, but you can use those different levels, right? So I'm going to get rid of the info level here. Let's see what happens and make sure I got this right. So I just have errors and warnings, okay? Now, if I click this, since it was errors and warnings only, let's see, am I on the right thing? Yes, log game roster. It didn't log anything, right? Well, because actually by default, didn't really need to choose that. By default, it's only info is going to be console.log is info, okay? Console.log is info. So if I change this to info now, there they are, right? There they are. They're kind of hidden. But you can go ahead, and this isn't necessarily going to be tested on this, but it's good to understand this and know this, right? So I'm going to want to change this just for fun here. Let's change this to warn. Okay, I'm going to save this, right? Once I save it, everything's gone there. Now if I come over here, okay, the first one, let's get rid of that. Let's get rid of these. So obviously you really want warnings and errors always to show. So you see those, but I'm just kind of making a point here. So now I'm going to correct here. It printed out that length, right? Because I left that, just that basic log, right? The warn, right? That's not going to print because I made that a warning, right? If I come over here now and do warnings, there it is. Get rid of info, right? So, but basically, you should always really have warnings and errors, probably info as well. That's the default here. If you click default, right? That's what it's going to be. Verbose usually go off and on with verbose, right? Now, let's see. So we had warn here, right, on this one. Verbose is not verbose. It's kind of can be kind of confusing. And so like even info is actually log, right? A little confusing. Warn, right? Error. So if you want the one for error, so let's just look at that real quick. Let's do that one. Error is going to have that little X like that, right? We probably didn't notice it. I probably didn't point it out. But if we do the warn, it should have a little yellow thing there, right? It has a little icon there. And now if I come over here and hit that, it'll have this little warning. It has a little triangle icon. The other one was the little red thing for error, right? Info doesn't have that. Let's see. Right? Info is log. A little confusing, I know. So if I go ahead and click that, it just doesn't have anything at all, right? And then the other one, though, kind of wanted to mention. I know it's a little confusing. For verbose, it's actually debug, called debug statements, right? So this is kind of like, here you are, you got this complex application, you're trying to diagnose something, you got a whole bunch of debug statements. You may want to leave them in there. And if you do, then you can make them debug, right? So now let me just even do both of those, I'll leave it. So I just got that one debug. So if I just click this, it's going to be just that second one, right? The first one, we made it debug. So if I click on verbose here, there it is, right? So then that's kind of your that's kind of your developer stuff. If you're really wanting to try to isolate something, try to debug something, you could use that, okay? Otherwise, by default, you can just use the log file, right? But you may want to have something. It can become very handy in certain circumstances where you really use those different ones for error and warning, because because there's some things that are really important. Maybe you're accessing something external to your page, right? What we're doing here is pretty much all client-side stuff. We're just working within our browsers and stuff on our own machines and that. But if you might be calling some external resource, you may be calling, an API, you may be calling a database, you could be calling all kinds of things. And there might be some situations where you're wanting to actually print out that, hey, there's a problem accessing this, right? And so you may want to have that in there so that it can be seen that that's a problem, right? And it's for mostly, like I said, most users aren't going to know about that and use it. But from a developer standpoint, from a, maybe a customer support, you're working with a customer support person is working with somebody, with some user, and over the phone, or they're sharing screens, whatever, and okay, let's look at this, let's look at that, you're having some specific issue, right? And then you can tell them, go to do this, and you look at the console, oh yep, I see what your problem is. Just throwing that out there. But those are the different ones that are available. Obviously, like I said, log is basically info. Then you've got warn, right? Warn will go ahead and put those little triangle things in there, right? Error, and then there's also debug. And then by it helps if I spell things right. Okay, debug, right? So those are different ones. By default is log. You come up here to all levels. You just click on default, and it got rid of the verbose one, right? Because I had that originally there to show you that. You hit default. This is what's going to be default in the browser, right? Unless you change it otherwise. Okay. All right, so that is that. Let's look at some loops here. We're going to do the run while loop here. Okay, go ahead and look. Let's look at the code for that. Let's get rid of this. Okay, here we're doing the run while loop. And so that we're grabbing the credit input value from the page, right? Get element by ID, and we're getting the value. Always remember that too. When you do a document get element by ID, this in itself is just returning that object, right? It's returning that HTML element object that's by that ID. Doesn't really return the value. Always, and this, developers make this big, especially beginning and stuff. It's you always got to remember are you trying to grab the whole element or are you trying to grab the value? So in this case, you're grabbing that value because we want the number of credits, right? So we're getting the credits there, and we're doing a while. So while credits is greater than 0, we're going to be printing these lines out, right? We're printing these. We're doing this output. We're just doing an output, and then we're doing the plus equals, right? If you remember, the plus equal is just going to keep on appending to this output, right? It's doing a new line character. That's why each one's on a new line. So you're just appending to this as long as credits is greater than 0, right? And here you're doing minus minus, okay? Without this, we can get an infinite loop, right? Because we're starting at a lot of times with count stuff, you start 0 base, 0 on up. But in this case, we're doing the opposite, right? We're starting at 5, 4, 3. It's a countdown. When you do a countdown, right, you need to do a decrement as opposed to an increment, right? When we're counting some orders or something, you keep doing another order or adding something to a order list, right? You're just adding, right? You're starting at 0, 1, 2, 3. This case, you've got credits. So in this case, you're going to decrement. So you're decrementing. And then once it's, as long as it's greater than 0, you have credits, right? So there you go. Then also, always remember this has got the pretest loop. This condition is checked every time, right? Our do while loop, run the do while loop. So once again, here we're grabbing wheel credit input. Up to 5. Let me put a 3 there. Spin the wheel. Spin 1, bonus coin. Spin 2, bonus coins. Spin 3, no prize. Total spins. So even starting at 0 credits, right, it's going to spin once. So we hit that, no prize. So it's still spinning, it's giving you a free spin, right? So once again here, make this a little bigger so you can actually see it, would help. Here you're doing a do, right? Don't worry about this random stuff. We'll talk about that later. But basically, you're just doing a do while as long as the credits is greater than 0, right? But this does get checked after your first spin. You're doing a do while. So it's automatically, not that this really makes sense, okay, to do this, but just an example, right? So in this case, you're basically letting them do a free spin, right? Even if their credits is 0. So the do whiles, this is going to be executed one time, no matter what. Right? And then once it's going to check this after it's finished, right? And then it will exit that loop if the condition is no longer a truthy value. Okay. All right. Leaderboard builder. Let's look at this. So this is our basic, our for loop, where we have our initialization, right? We have our initialization. We have our condition here. Right? And then we're doing, an increment or decrement. In this case, we're just doing an increment, right, to our I variable. Um, I is very commonly used. I, J, especially, and then very common people use I. Um, Also, could use and then people do inner loops with J's or K's, um, but you know it's not always good to do that. You can always sometimes have a variable being something that's more usually for a for loop though you're just incrementing through things, so it's not does that variable always help um, define something. You kind of know by looking at it. Leaderboard.length is you're basically just looping through your leaderboard, and you're just using this as a uh, a value that you can increment. Can you call that? You can call this whatever you want to call it, right? You're defining that variable. You just have to remember whatever the variable name you give this, it also needs to be the same as here, right? Um, and then anytime if you do something else and relate and access that variable, you need to make sure you use the correct variable if you're accessing it within your loop. Because I was originally saying you should really define something, but usually for for statements, it's not so critical. A lot of times you're going to see a lot of people use I or J, especially like nested loops, and then inside your nested loop you do a J and then that, right? Because really it doesn't really tell you a lot, because by looking at your for statement you already know this is your leaderboard. You're looping through a leaderboard, right? So you're just providing this. But when you're using sometimes other things, right? Because this is only within this statement itself, within this thing itself, right? This is only defined and used within your for statement. Once you're done with this, it doesn't really matter, right? This is just for counting. But what is this? This is build our leaderboard. We'll just click that, and then here we go. We're looping through all of these. Pretty straightforward here. Okay. Let's look at our render cabinet grid. Okay, our render cabinet grid is going to be building this grid out, right? 2D cabinet grid. I'm going to click on this. So there you go. There's your grid, right? Let's look at the code for that. So you're getting your whatever's defined as your arcade grid, right? Is basically this element right here, right? If I do here, I click inspect. Here's your grid. So here's your div, arcade grid, and then you're actually building these divs, building this grid cells, right? Is what you're doing. We already did it. If I hit refresh here, and then went over here, maybe it can still find that. Let's see. No, it didn't. But okay, let's go back to here. So basically, it's getting this get this element our arcade grid. Which, if we looked at the JavaScript here, I guess we can do that, or look at the HTML. So here that's the second one. Arcade do. Here's your div, right? Even though this is all you see, you built this dynamically, right? By clicking this button. You took this and you went ahead and inserted others, right? Inserted your grid right there. Okay. So you grab that div, right? You're setting your inner HTML to empty, grid.inner HTML to empty. The reason you'd want to do something like this is you're kind of defining this this variable above your for statement. So when you're done, you're adding to this, right? You're adding to this. So come down here, and you're basically arcade cabinets.length. And so you're doing a for loop, your outer loop, you got an outer loop, you iterate over the rows, and then the inner loop iterates over every column in the current row, and the inner loop runs to completion for each single outer iteration. Okay, and you're using that insert adjacent HTML, right? So it's going to insert. So this is what it inserted in that div tag we looked at in the HTML, right? It's inserting this for each one, and that's the inner one, right? As opposed to the outer one. All right. So let's go ahead and you can look at these yourself, obviously. For each, so we're going to run our for each here, list scores. Here's our different scores. Let's go ahead and go look at some of the code here. So for each, you're using the for each. Right? So once again, for a for each, as opposed to like a traditional for statement or that, you don't have to worry about incrementing variables and getting stuck in loops. You know, sometimes it works for some things better than the others, right? Especially if you don't know, if you don't know how big your for loops work well when you know how many times you want to loops through something. Obviously, you can get your array and do it by length and stuff, you know. But there's sometimes, you know, it just kind of works a lot better using a for each, and especially, you know, when you're wanting to do something to it, right? You're wanting to do some callback function or whatever, right? But this is just showing you basically a simple little for each, right? And then you're basically the name you're giving it is player, right? So basically, this name you give it here is basically your array, your increment in your array, right? The next one. So you come in here, boom, player. Player is going to be the current element on each iteration, right? So you'll enter you're iterating through this, and it's going to be the current player for each iteration. Okay, so that's pretty much of a straightforward one there. The next one here is the map, right? Let's look at this. So a map calls the callback for every element and returns a new array. So always remember, maps return new array. It's going to overwrite. Here, you're not updating your array, right? You're just looping through this array, doing some stuff. You don't change anything, right? For a map, you're actually taking your original array, all right? You do a map on that. Here's your callback method. And based on this callback method, you're changing your array. Okay? You're creating a new array. I'm sorry, you're not changing, you're creating a new array. You have a new array called boosted scores. So you're taking your leaderboard array, right? You're doing some manipulations, and then you're saving that to a new array called boosted scores, right? So let me click on that. So here was the weekend one-time find bonus scores. Okay, yeah, here's the original one, right? So it still has your original one, right? This was the leaderboard, right? This was your leaderboard. And now this is your boosted scores. Here's your boosted scores. A different array. Okay, let's look at the filter one. So filter calls the callback for every element and returns a new array, also containing only elements where the callback returned true. Okay. So in here, you're doing this filter, right? And then you're populating this array, right, with the results where the player score is greater than or equal to some threshold. And so here's your threshold. So basically, if it's not greater than equal to, your top players are not, is only going to be the ones that meet those criteria, right? And that's a filter. So let's go ahead and click on that one. So players with a score of greater than or equal to 10,000. These are the two, right? 2 of the 5 players qualified. Okay. So once again, your leaderboard is still your original array, right? Now you have a top players array that has these 2 here. Okay. Next, let's do run find. Okay, find returns the first element where the callback function, callback function returns true. Okay, find's just going to go find the first one. So if you have multiple in there, you're wanting more than multiple, find's not going to work, right? It returns the first element where the callback returns true, right? So here you're doing if the player score is greater than target, right? For our filter, we return these 2. So let's go ahead and do find here, right? Which was the face one, right? The ace X one, right? The filter had 2, right? It's going to just return that one. And there you go. Okay, next let's look at reduce. So reduce combines every element into one accumulated result. The callback receives the running accumulator and the current element. The second argument to reduce is the starting value of the accumulator. Okay, and I know that can be a little bit confusing. Spend a little time, look through that. So here reduce totaling all scores, right? The second argument to reduce if the starting value of the accumulator. Okay. It adds the player's score to the running total. So here's a score. You're adding it to the running total. And it's, the 0 is the accumulator starting value. So here is where you assign the starting value of the accumulator, right? And that gets added too. So let's look at that a little more here. Let me find something for this that might help explain this a little better. Okay, so W3 schools here. Subtract all numbers in an array. So, that's a basic example here. It's showing us this. Sorry. So it's important to look at this. So the reduce method executes a reducer function for an array element. The reduce method returns a single value, the function's accumulated result. Okay, it's accumulated result. The reduce method does not execute the function for empty array elements, and the reduce method does not change the original array. So you're not changing a new array, right? It's just returning an accumulated result. Okay, it's returning an accumulated result. All right. Okay, let's look at some of this decision-making ones here. Should be pretty straightforward here. Don't worry about reduce too much. I know it takes a little while to grasp on that. Decision-making, if else, else if. So let's go ahead and just telling your ranking here. Right, gold. So let's go ahead and take a look at that. calculate the rank, right? We calculate the rank, go to definition. Here's that score, parse int. So, and that's another one, you always got to remember to, if you're getting a value, remember all the values on an HTML page are going to be string, right? They're not going to be numeric or whatever. So you have to take what's on that page and you have to parse that to an integer, right? Especially if you wanting to perform something on that, some kind of numeric functions on that, right? If you wanted to check if its value is greater to a certain thing, right? You're going to have to make sure that you go ahead and parse that to an integer first. And always remember this by itself only gets that element. If you want the value, you need to do that value. So that's getting your score based on what you put in that's what that is for that element. So here's kind of doing a kind of validation, right? This is a validation. This is checking, hey, is this score a number or not? Is not a number. If it's not a number, right? So let's just put something else. It's not a number. And hit calculate, enter a numeric score. It won't actually allow me to put in anything but a number, right? Because that's how it's set up. But if you put an empty thing, it's going to be as a not a number. Okay, so this is basically doing, you're coming in here, you grab your value of the score, and then if it's not a number, you're returning. You're not even doing anything else, right? Else, we're going to come down here, right? And we're going to do a nested one, right? We're doing else, else if, else if, else if. So if it's greater than equal to 15,000, it's platinum. The last one entered was 20,000. So platinum, right? Else if, right? Why you really want to make sure you just don't, you can actually skip all these else's, right? But the problem with that is it's going to go ahead and if you skip your else's here and just do a bunch of if statements, it's going to, if this matches, it's still going to execute these other ones. And it's going to end up changing it because basically if you skip your else's here, it's going to, the first one, if you had greater than or equal to 15,000, the rank's going to be platinum, right? The badge is here, right? Here's your rank platinum. If you skip your else statement, you didn't have an else statement, it's going to do, if it's greater, then it would change it to gold. Even though you put in 20,000, it's going to be gold, right? And if you did the same thing here and didn't have an else statement, it's going to be silver. So you just kind of got to watch that so you don't accidentally sometimes put yourself in a situation where it's not really executing what you expected, right? Students, I've seen that happen a lot. You got to really think through your if and else's, right? Because sometimes you do want to do an if and then you want to do another if in certain circumstances. Just kind of depends what you're doing. When you're checking the same things and you're doing a greater than or equal to, yeah, you need to really look through that, right? So here you're doing an if and else ifs on all these scenarios. If none of these match, right? This is only going to be executed, right? If something else doesn't execute here first. Okay. Check the VIP. So here we're checking, we've got a button, a checkbox, not a button, checkbox, right? Checkbox is different than a radio button, right? We're doing if this is checked, right? So if the is VIP is checked, then we check VIP access, but no score. Keep playing. It's because it's checking that score, 1, 2. Let's see what happened there. I don't know. Yeah. That's okay. What do we check? What is score equal to? Parse int, VIP score input. Oh, duh. Not even paying attention here. So VI, there we go. Now we're good. I'm sorry. So VIP lounge access granted, VIP member with qualifying score, right? The qualifying score is 10,000 or greater. So this is doing a nested if. So usually you're doing that if you want to kind of check. You have one condition you need to make sure is true before you check some other conditions. In this case, you need to check. You don't even care about the score unless you know until first you know if it's a VIP member. If it is a VIP member, right, then you want to go ahead and check the score, right? You're going to do this. So if it's not, if this is falsy, if this is false, then you're going to do this else statement, right? Not a VIP member. Okay. Browser test. Test if else that checks whether a feature exists before trying to use it. Is supported in this browser. We could not safely call it. Okay, get current position. So there are settings that you go on the browser, right? You can change it so things are not tracked as much, right? You got a lot of different settings in a browser that can be used. So, but it's going to first going to find out if it's supported. So if it's supported in the browser, that don't mean that you can have some things that are disabled, so it can't get the current position without you allowing that, right? Depends on your settings, your browser settings that you've your user browser settings that you've decided on. Okay, switch statement. Let's look at a switch statement here. And describe game mode. All right, so I just chose the first one, which is, okay, story, right? Let's see. Story, I selected the second one. Versus mode, survival mode, and practice mode. So I got versus mode. Describe game mode here is the function. Let me open that up. So basically, what you want to make sure you do here, I repeated this multiple times. Make sure you're getting the value, right, from your element. However you get your element, you need to make sure you get the value because that's what you're going to be doing, right? So that's your mode. Your mode is this, the value of this select, right? So if it's story, here's your description, and then a break, exit the switch. Don't fall into the next. You don't need to check anything else. Once you find what you need, you break out, you're done. No reason to execute anything else, right? And obviously, as we looked at that example earlier, we had Saturday and Sunday, that we had weekend hours. So that time, sometimes you do want to have two cases in a row without a break, but you just need to be very cognizant and be careful. Make sure that you're handling that right, so you're getting the correct results. But once again, and then you always have to make sure you got a default. Okay. All right. Next is intentional fall through. So intentional fall through here. Okay. So yeah, this is that one thing. Same as the example in the guide where for weekends, you're going to have different than during the week, right? So here I'm going to select Saturday, show hours, weekend hours, right? 11 a.m. through midnight. So let's just look at that real quick. So here you got case Monday, Tuesday, Wednesday, Thursday, right? So different hours on different days, right? Monday through Thursday, weekday hours are 2 p.m. to 10 p.m., right? Then you're going to break out of that. If it's Monday through Thursday, any of those. If it's Friday, you're open till midnight. Saturday and Sunday, right? You're open earlier in the day and then till midnight. So if I do this Friday here, Friday is open from 2 to midnight, right there. If it's a Saturday. So really, you only, yeah, you have a couple different fall throughs, right? You have Monday through Thursday, right? All this refers to all of those, right? This is your result for all of those. Then you break out, right? If it's one of those, so you're checking one or any of these, then you go ahead and this set your hours to this, and you break out. Otherwise, you're going to check for case being Friday and set your hours for that one, and or if it's Saturday and Sunday. And always remember, you got your default at the end. I don't know how it could be closed on a day that's not every day through Monday through Sunday, but that's okay. It's closed. All right, let's look at loop control. Let's look at this. Search with break. Search for player. Pixel Kid, did I do that right? Found. Okay, let's go ahead and look at that. So basically, you got a for statement that you're just looping through your for statement, all the things. You got an if. Once it finds it, it's going to break out. It's going to exit the loop immediately. No need to check the rest, right? Breaks out of your loop. So don't get that confused with breaking out of an if statement or anything, right? That doesn't, right? Basically, that's not how you would do it, you know, if you want to break out an if statement. But this will break out of your loop. The if this condition is true, right, it's going to break out of your for statement. Okay. Next one is continue. So let's take a look at that. Sum with continue here. Okay. So here we've got some scores where we've got a couple undefines in here, right, as an example. You know, and here's another example we kind of talked about. We didn't look at much, you know, where you can, with an array, you can actually have different value types in there, right? So here we've got some numbers, some numeric, some integers, right? And we've got undefined, right? That's a different type. So, and here we got some different types. And then we're doing our for statement, and we're looping through all of our scores, right? But if our score is undefined, right, we're just going to continue. So we don't want to add those to our total. So we just keep on going. We're going to go to the next one in the list, right? When we hit our continue here. So if it finds undefined, okay, let's leave this and go to the next iteration. Okay, labeled loop. Let's take a look at a labeled loop here. Let me go backwards here. So that was that one. Okay, so I'm going to search for Pixel Quest here. And as you can see, it highlighted here. Okay, let's go ahead and look at the code here real quick. So this one we might want to make a little bigger. So here, render the grid first so we can highlight. So, you know, we're just rendering the whole grid here. Really the part we're really wanting to care about here is this, where we've got an inner loop. So here's our grids, and we've got this labeled name, grid search, right? So basically we've got our since we've got the multi-dimensional array here, we're looping through our arcade cabinets, right? Right? And then inside there we have, got rows and columns, right? So then we need to go look for that specific name, right? And if we're using this word target here, where we define target up here. Here's our target. So that was the value that we put in there. In that field. And then basically we're looking for that target. If we find that target, right, then we're going to break out of the grid search. So we want to break out that we're using the label so we can break out of the outer loop, right? A lot of times people grid search, a lot of people do outer, maybe that's not always the best, but this is a little more descriptive. A lot of people do outer loops though too, especially, usually it's an inner loop and an outer loop. I guess you could have multi ones that, but outers, I've used outer a lot through the years for things like this. So outer is fine as well. Here you're just defining it. You can put anything you want for the label. Okay, so that's it. I know some of this stuff, maybe a little more complex, maybe like the reduce stuff. You need to kind of go through that maybe a little bit more. But work through your assignments. The book stuff will really help you get going on that, and the written test and stuff, and you should be good. Not all of this is going to be. We're not going to be doing all of these things, right? These are just some other things just for your own information. But it's helpful to understand these and to understand when and how to use them. Okay, so that's all I have. Please let me know if you have any questions, and have a great day. Thanks.